All right, hello everyone, this is Mr. Crozier. I had some questions on the review packet number 2, so here we go. First question I had was for number 20. Differential equation gives the rate at which Elliot walked across the room. So let's see what this is looking like. If I graph this, y is equal to, let me erase those, 3x squared minus 10x plus 5. And if I graph that, there's this area down here. Let me zoom it in better. Let's zoom a box. There's time where he walked forwards and backwards, and all of this negative time right here from this point. And if you trace that point, that's about 0.6. From about 0.6, and that's on my paper here, from about 0.6 to 2.7, he was walked backwards. So I'm going to integrate all of that area right there, and that will tell me the backwards walking because that's the negative area. On number 21, same deal. You can use your calculator to graph this. Make sure you're in radians, and you will find a minimum value and a maximum value. So you can just use your min and max on your calculator to do that. After you graph it, make sure you're in radians. All right, on number 23 here, the work is here. Now, possibly, I believe when I did this originally, the equation that I did is I didn't store the whole equation in there. So you take this table, and you put this table in your stat and edit, and when you go to do your variable work, and you're going to do an exponential regression and get this equation and store it in there, you're going to get slightly different numbers than I did right here, and that's fine. So your answer may be off by a little bit, but I got the average temperature of these. Looks like it's about 50. It's somewhere in there is the average. So if you do this, you can get an average. Now yours may come out slightly different. That's fine. And then when you get down to the second part, you're going to want to find what time makes that average. So we're going to solve this equation by dividing, taking natural logs. And again, I believe when I did it originally, I didn't store the equation in there, so you may have different numbers, but that's fine on this problem. 25, solve the differential equation. Well, I put my dx over here, and I put my y over here, and then I just integrate this with the reverse power rule. Same thing there, and I get it to solve. And then I just take the reciprocal this side, reciprocal that side. And it would be okay to just take that constant out. Maybe we should have done that from the beginning and just write that constant out there all by itself. All right, on number 34, we're going to have this shape here. And if you graph it, you will see that it goes from 1, 2, 3. And we're using the formula. They're going to be disk. So it is pi r squared. We're making a bunch of circles over here. So all of the circles would give you 16 pi over 15. On this problem, however, this one's a washer problem. So if you notice what I did here, I did pi r squared of the big one, the outside one, and pi r squared of the little one, which is on the inside. So little minus inside circles, because it is revolved around this axis. 38, volume when it's revolved around the axis, pi r squared, they would be disk. Disk problem, washer problem. All right, going on to some more. Here we go here. On number 39, it is another disk problem. So it is pi r squared, but if you notice this, the r is only this distance right here. So the r is top minus bottom. So it's top minus bottom is the r distance. And 43, I went ahead and took this function, took its derivative. Here's this derivative. And the formula for arc length is the integral of the square root of 1 plus its derivative squared. So that can be typed right into your calculator. Same thing on all of these. If you take the derivative, the formula is square root 1 minus derivative squared. I just remember it's integral square root 1 plus the derivative squared. Same on that one. On this one, you could get this to arcsine. You could get this to arcsine by doing all of these substitution steps here. And you can get all the way down to 3x here and x squared dx, and there's your du. And now it's a root over a du, which leads you back to arcsine. All right, I hope this helps with your packet.